All right, welcome everybody. We are in Unit 2, and we are doing topic number 2, modeling with graphs and equations. That word modeling, when it comes to math, usually means that we are taking a math concept and giving it a real-life context, so some sort of application in the real world. We're just going to start by reading this first problem, and it's going to describe our real-life concept or application. It says, the following graph, this graph right here, represents the height of a volleyball serve as a function of time. 3 specific points on the graphs have been labeled for you to answer the questions below. So let's make sure that we understand what that means. First, it says 3 specific points have been labeled. Let's just make sure that those points are labeled. I'm going to zoom in a little bit more. I'm just going to make that point look a little bit bigger. Here, 1, 2. We have 3 points labeled. And before we even answer the question, let's see if we understand these points. So we're talking about a volleyball serve. If anyone has ever played volleyball, what that means is that a serve is when you start the game. I'm going to draw a little stick person here. This is my person that is serving the volleyball. She has a volleyball in her hands. And this should represent, it should seem real life to you. If you've ever played volleyball before, you hit it, the ball goes up and over the net, and eventually it comes back down. Okay, so again, this is where we start. I'm going to write the word start here. And then the volleyball leaves the person's hands who's serving, goes up, and eventually comes back down. And we're going to talk about why these points are so important: the start, the top, and the end. All right, so the first question says the point 1, 30 is on the graph. And 1, 30 is not labeled, so let's just find this point 130 and label it. So x-coordinate is 1, that's right here. Y-coordinate of 30, and you should be able to see that point. And let's just plot it right on our graph, 1, 30. Fill in the blank to describe what that point means. So it says after blank seconds. Now the seconds are on the x-axis, so that means that I'm going to use the x-coordinate of my point, which is the 1. So after 1 second, the volleyball is blank feet high. The feet is my y-axis, so I'm going to use my y-coordinate of 30. So after 1 second, the volleyball is 30 feet high. So this point 130 gives us a lot of information. It's not just a random xy. All right, the next one gives us another point, and we're just supposed to write the same thing, our own sentence. And this time it's talking about the point 2, 24. And so I'm just going to take a second to put an arrow. 2 is my x-coordinate. Remember, my x-axis is time. So this is going to be my seconds. 24 is my y-coordinate. My y-coordinate is the height. So this is going to be the height in feet. All right, now we write our own sentence. So for this sentence, I'm going to write it just like my other one, and I'm going to write after. And this time our x-coordinate is 2. After 2 seconds, the ball is, my y-coordinate is 24. 24 feet high. And that's my sentence for part B. All right, so moving on to part C, I have another image of my graph over here, the same graph as you guys have. The part C asks, how high off the ground is the volleyball when it's served? And I just want to pay special attention. If it says how high off the ground, that is giving us a really big hint that your answer will be in feet, because it's asking how high. So it wouldn't make sense if our answer was in seconds. Our answer should be in feet. All right, and it says when the volleyball is served. Remember, in our previous image, we drew a stick figure right here, because this is the start. This is when the volleyball is served, right? So how high means when the game starts, what is the y-coordinate at that point? And the answer to that is 4 feet. And if you ever played volleyball, that should make sense. 4 feet. When you serve the volleyball, it doesn't start on the ground, it starts in your hands. So the person that's serving this volleyball is probably around 4 feet tall, maybe a little bit higher. So the ball is 4 feet up. All right, part D. Part D says, how long does it take for the volleyball to hit the ground? So think about this. If it says how long, your answer better be in seconds, because if you said feet, it wouldn't make sense. How long does it take the volleyball to hit the ground? So let's think about this in real life. This is our start. We hit the volleyball, it goes up into the air, reaches a certain height, comes back down. This is the most important point right here. This is when the volleyball hits the ground. And the y-coordinate of this point is actually 0. Look at the y-coordinate of this point. It's 0 because it is 0 feet from the ground. So this is our answer of the x-coordinate, 2.717. So our answer here is 2.717 seconds. And I'm going to abbreviate seconds, SEC. All right, let's do the next one. When does the volleyball reach its maximum height? The question says when, which means my answer is going to be in seconds. Maximum height means its highest height. Follow this volleyball. Going up, going up, going up. This point right here is our maximum height. When does the volleyball reach its maximum height? My answer should be in seconds, so I'm going to use the x-coordinate of this point, because 1.31 represents, here's its maximum height, I go all the way down, it's somewhere in between 1 and 2 seconds, 1.312. 1.312 seconds. All right, last question. It says, what is the maximum height? What is the height that the volleyball reaches? So that means I'm going to still use that point we just talked about. I know that this maximum happens after 1.312 seconds. The height that it reaches is the number from the y-axis. So if I look at my point and I go over to the y-axis, see how it's right above 30? That's why this answer makes sense, 31.563. 31.563, and this time our answer is in feet. All right, so we're moving on to another application. This application is not about volleyball, it's about caffeine, my favorite. So this says, Jasmine drinks a coffee every morning. She is told that as the day goes on, the amount of caffeine in her system decreases, that means goes down. Below is a graph of the amount of caffeine in her system as a function of time. Use the graph to answer the questions. So if you've ever had a coffee, you know that when you first drink it in the morning, you feel great. You have a lot of caffeine in your system. But as the day goes on, the caffeine wears off and you get tired. So in this case, this graph looks very different than our previous graph, because if you remember, our previous graph went up and then came back down. This graph just is always going down, because she starts off high on caffeine, and then the amount of caffeine goes down, 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 until eventually there is no more caffeine in her system. All right, so the first question says, how much caffeine is in her system at the beginning of the day? So at the start of the day, and look at, this is the time in hours. So the start would be before the day has really started, right here at 0. And if we look up at the graph, the start of our graph, it looks like that she has 20 milligrams of caffeine in her system. And then it says after 1 hour. So 1 hour tells me I look at the x value for hours. After 1 hour, how much caffeine is left in her system? So I'm going to go to my time, going to go to 1 hour, and go up to my graph. And you guys see how I end up right here is where I hit my graph. And I'm going to actually put a point right there. And I'm going to put there 1, 10. And I'm going to put over here 1, 10. And that doesn't answer my question. How do I answer my question? It says after 1 hour, how much caffeine is left in her system? So the answer to this question is actually the y-coordinate. This point means after 1 hour, she has 10 milligrams of caffeine left in her system. So 10 milligrams. This is my answer right there. All right, next question. How long? Remember those hints from last equation. How long means my answer should be in hours, time. How long will it take for there to be 5 milligrams of caffeine in her system? So this time I'm given this number 5 milligrams. So when I go to my graph, I don't look for 5 on my x-axis. I look for 5 on my y-axis for milligrams. So I'm going to go up my y-axis, right in between 4 and 6, that gets me here. And now I'm going to go over and find my graph, and I should end up right here. I want you to plot the point right here where my cursor is. So it's going to be right there. And that point is 2, 5. And I'm going to put that point right here. Now that doesn't answer the question. The question is, how long will it take? So I've gotten my 5 for milligrams. My answer is this number 2, because 2 came from the x-axis in time. So my answer is 2 hours. Alright, for our last problem in these examples, we are doing an application that we are very familiar with. We've done so many of these in Unit 1. This is talking about joining a gym, and it says that this gym charges you $40 down, and $5 per month. $40 down is another way of saying $40 right when you join the gym, even before you attend the gym. $40 as a down payment. So my 40 is here in my equation. And then $5 per month. And if you remember from your Unit 1 test, one of the questions was, why is there an X next to the 5 and not next to the 40? And the reason is because the X stands for the number of months that you're a member of this gym. And if it's $5 per month, your cost will go up if you're a member for a lot of times. So this actually means 5 times however many months you're a member. Alright, so now all that we're going to do is use this equation that's already given to find out the prices for a different number of months that we go to the gym. Remember, we said X is the number of months. So if we go to the gym for 0 months, how we would figure that out is we would do 5 times 0 plus 40. Because we're not a member, we don't have to pay the monthly fee. We just have to pay that $40 down. And our answer, if you do 5 times 0, you get 0, plus 40, you get 40. And what that means is the point 0, 40 should be on our graph. And let's just test it. 0, 40 is right there. I see it. All right, let's do what if you are a member for 2 months. So for 2 months, you're going to do $5 a month times 2 months plus 40. 5 times 2 is 10, plus 40 is 50. So X, our number of months, is 2. Our cost is $50. Let's go to our graph. 2 on the x-axis, 50 on the y, there's a point right there. Next, what if you remember for 4 months? $5 a month times 4 plus 40. We do 5 times 4, that's 20, plus 40, we get 60. So this point is 4, 60. Let's check and see if it's on our graph. I see it right there. And then lastly, $5 a month if you're a member for 5 months, and then plus $40 down. 5 times 5 is 25, plus 40 is 65. That means a point on this graph is 5, and this is in between 2 points, so just make it right there. 5, 65, and that should be right there. So since we know that this graph right here goes with this equation, if we plug in numbers, X, we'll see that they are going to fall on this equation. We'll talk about that a little bit more in our next couple topics. Alright, so we just finished topic 2. You should be doing your Unit 2 homework number 2 tonight. Good luck.